Hello, everyone. Welcome to my next installment of a knife making extravaganza. In this episode, we're going to be making a knife that converts into a push dagger. It's kind of like it's okay push dagger, okay knife, a little bit of a compromise, but it's a backlock. It's a backlocking knife, and so some critical dimensions in here to fit up. But let's jump into this. So this knife is going to start out as some twist Damascus. Now I made this Damascus in another video. I'm not going to cover how to forge out pattern welded steel and draw it out and twist it, but this has got a pattern in it, a little kind of a helical pattern. So it's been twisted and flattened, and it's kind of in like a rectangular bar. So here's my furnace getting up to temp. Furnace temp on this operation is around 1900 to 2000, somewhere around there. And the first step is going to be kind of flattening this out and making sure I'm getting any of those ridges. There was a few little cold shuts on the, you look at those little ridges on the edges of this billet. And so I'm going to make sure I leave myself enough material so when I'm going to grind down. So sometimes these corners can form little folds, cold shuts or inclusions, whatever you want to call them. The steel's not fully fused, but I'm going to leave some material grind back. You can see I have a little piece of steel there. I'm using that as a spacer to make sure I'm getting a consistent thickness. So I'm drawing out this push dagger, and I want to make sure that the pattern kind of morphs down along with the blade profile. And so here I am on my last heat, and I'm making sure I'm getting this point consolidated. Usually the last half inch is sacrificial on a point like that. There's usually some type of problem with the steel right at the tip there, but so I'm just getting the general shape, going to flatten this out, and then I'm going to put a little kind of ridge in the back of this. This is going to kind of have like a tapered section and then a circular little tail on the back end where it pivots inside the knife mechanism, inside the handles. So I'm getting everything at consistent height. I do rework that edge a little here using my little DIY anvil. It's a railroad track. It's okay. I need to step up and get a legit anvil, but they're expensive. But I am exploring some other options on a better anvil. But I'm just truing this up, getting this kind of straight. Now the rest of the straightening I handle here with my belt grinder. I'm at a coarse grit here. I think I'm at like 80 or 100, and I'm just making sure I'm getting this. These sides are parallel, and there's a slight little delam or inclusion. I'm not sure what it is, and thankfully you could barely see it, but it ground out. So I was very relieved. You can see it right in that little area right there, but it ground out. So I cut this off with my bandsaw. Ting! I love that sound. Uh, Now here's kind of the shape. I have my template. I'm going to go over this. This is a rough. It's pretty close to the actual blade. So I cut those reliefs in with a 3/4 inch diameter end mill, 4 flute end mill, and I cut those in and very precise. And then I do a little bit of beveling work, and then I made sure I was a consistent thickness on this blade. So I'm using a concrete cutting blade material. This piece of steel I'm making the handles out of is from a concrete saw. Um, Surplus blade that was just kind of tossed in a bin. Its life had been exhausted, so much like my own. But anyway, so I cut out this blade. You can see here the fit up. I drilled and tapped a hole on one side of this, and I'm going to use this as a profiling kind of. I can clamp both these sides together, do some profiling here. So nothing fancy. I clamped these two pieces of steel together, and I used a Dremel tool with a little sanding drum to get these contours. Nothing real fancy, just I clamped these together with a 1/4 inch by 28 threads bolt, And I just went through contouring these. So they're identical. So this is a good trick if you ever want to contour a pair of things and get them perfect, just clamp them together. And this method works well for contouring. So each one of these pieces is 0.110. So just over a tenth of an inch is the thickness of these. So I'm going to be making some bronze washers. They'll fit in between and help. They're kind of like a self-lubricative. They're much softer than the steel. They really help the pivoting mechanism. So I use a narrow cutoff tool, parting tool it's called, and I part these off. Each one of these is 0.050 thick. That's 50 thousandths is the thickness of these washers. Here's both of them. After they parted off, I've sanded them with 220 grit sandpaper and mic'd them. They're both 0.050. And they'll fit on either side of the blade here. And they're like a low friction. You can use different types of things for this. I've seen spring washers. You can use a bearing, actual ball bearings too. But now these are the spacers. I made two of these. One actually gets welded to some square stock, but these were threaded 632. I'm going to be using stainless steel 632 threads to hold the sides together, but this is a steel spacer. I make two of these, and they're tapped all the way through with a 632 thread. So once these were made, I can mock up my blade here. The handles, I had them clamped together, and I drill for this as a through hole for the 632 bolts. And then those also get countersunk too. They get a countersink. So here's one of the spacers, and the front spacer acts as a blade stop. The blade will rest up against that. So this is the backlock mechanism. I didn't spend too much. I'm not going to spend too much time explaining the geometry of how these work. They can be finicky to tune and to get the fit up perfect, but this is 1/4 inch thick steel. That's 1095. So here's the profile. I cut out a template. I traced it onto the stock, and I used that to grind this shape. Now, once this notch is fit up, and I got it really close, I'm going to clamp it in place, and then I'm going to drill for the pivot point for the backlock mechanism. And there's going to be two notches, one that will lock the blade in one position, and here it is. This is just a mock-up, and the fit of these cannot be overemphasized. There shouldn't be any play, and so a lot of these parts haven't been heat treated yet. So and there's another spacer I made on that post there for the backlock, but this is just a fit up now. I'm testing the interference of that and the tolerances of these, some of the play here, but I'm going to heat treat this backlock mechanism now. Just the front part of this is going to get heat treated. So the part that locks in to the blade notch, and then the pivot pin area too, those are hard. And I got now I got my blade all set up. I do a heat treat on my blade, and so this is after heat treat, and I have my spring installed, and then I don't show how I made that little spring pocket, but that was out of some square stock that got welded to that spacer. Now look at this fit up, guys. There is zero play in this fit up. So zero play. This blade locks up, and it is locks up solid. And in both positions, there is zero play. And that front pin acts as a blade stop. And there's another blade stop that'll get added later, but this is just I'm verifying the fit of all these after heat treat. And I can use sandpaper to kind of dial in these interface, how these surfaces lock up against each other. Because that backlock kind of cams into position, right? It doesn't just drop straight in. It's not linear. It kind of takes a little camming path. But so, oh, I'm getting so close. This is backlock knives for me are a little harder than most folding knives. with a standard, like a frame lock or a liner lock. But so it was a while. I had done quite a few knives before I even attempted a backlock knife. But and the heat treatment of those surfaces need to be, there's a balance of the heat treat where they interface, where those parts lock up. So I'm beveling here. This is after heat treat, and after I did a tempering cycle at 250 degrees for an hour, and I'm grinding these bevels and getting closer and closer. I finished with 1,000 grit belt and got those bevels. Was actually pretty sharp at that point, but this is really close. All that's left is the finished polish on this now. So I polished 400, 600, 800, and then 1,000. Um, and so this blade came out pretty good. I was really happy with the heat treatment and the temper, and I took my time on these progressing through these grits. And you can usually stop at 400 grit if you're going to etch in ferrochloride like I did, but I really wanted I like this look. And you can almost, this is polished so well, you can almost see this pattern. Now I have an etch coming up, guys. This came out phenomenal. Look at the pattern on this. I think I must have stared at this for like 15 minutes. I love this pattern. The polish came out nice. I might, I think I etched this. I put it back in the tank. It's a little darker. I don't know. Let me know what you think. Should I have kept it shinier like this, more contrast, or I wanted it darker? So I think I went back in. The blade is a little darker. Now, the pins for this, rotating pins, I'm going to make a mosaic pin. Now, this is a piece of hydraulic gear from a hydraulic motor. It's very large gear. It's about 2 inches in diameter. So I press this into some chromoly tubing, some 4130 chromoly tubing, and then I weld an end cap, and then I fill it with fine powder. That's a 2% nickel content. Okay. And then I weld another end cap on it, and I weld a handle on it, and I start drawing this down. I get this up to, this is forge welding temps. I get this to around 2250. Okay. And you can see this can vents a little bit if you can see the gases venting here. And that's fine. At this point, it's pretty much fused. And the ends, I discard the ends anyway. So I keep drawing this out. I don't show all this. This was time consuming. I draw this out to it's about 3/4 inches in diameter. It was like 3 times the length you see here in this last shot. But so I draw this out to down to 3/4 inches of diameter. Okay. And here's what the rod looks like when it's done. Now look at this pattern. You can see that gear pattern. And the gear was carburized. Look at that black line. So the surface of that gear was carburized, so the carbon content's higher. That's what that dark little outline is. And the nickel's a little shinier, and then there's a gray in the center. And look, I had a problem with it fusing, but that's fine. These will get drilled out and threaded. These get turned into threaded collars. So here's they are after machining and polishing. I polished this to 1500 grit, and it's threaded quarter 28 threads to screw into that one of the sides of the handle. Now these will get etched, and you'll see that pattern. I haven't etched them yet. That's coming up. But so all the parts are done, and now I'm going to parkerize all the small parts in the blade. Here's the finished handles. They've been sanded to 400 grit, and they're going to get dropped into my parkerizing solution at 175 degrees for 15 minutes, and it gets a nice, look at this black, a nice even black. These have just come out of the parkerizing tank, and they get dipped in a displacement oil to get rid of that parkerizing solution. Here it is, guys. Check it out. This one came out just phenomenal. Look at the blade. The pattern on the blade, I love it. Look at that mosaic pin. And you can see it's almost like it looks like an amoeba. I don't know. And one of the pins came out with a higher contrast. I'm not quite sure what happened there, but this backlock mechanism works perfectly. Zero play. I use stainless steel 632 countersink bolts. Now look at this. See how this I had a little difference of etching on the one, but I actually like that. You know what? I actually like it. I like it being varied. Um, and this thing is, I should have had some paper tests in it. This thing is, I'm not exaggerating. It is a razor. This thing is like a 3.5 or 4 inch razor. Uh, and matter of fact, I was handling it. I was just being really careful as I was handling it. But um, let me know what you think. Do you like these mosaic pins? Are they all right? I don't know. I was trying to do something. Each knife, guys, I'm trying to do better. I'm trying to increase my quality and my creativity with each step here. But I love these pins. This one looks like I'm not sure what it looks like, flame or an amoeba. And the fit up of these components came out perfect. This almost looks like it's on fire. I don't really know. What does that look like? That pin. Um, but this mechanism, and I pressed a pin into the blade, and you actually have to use that. There's really no safe way to retract it, and you don't want to grab that blade. You would cut yourself. So that little pin in the blade, you can kind of see. You can use that to lock it in either position without having to get your fingers near the edge. But I'm really happy with this one, and the lockup on this is just perfect. It's there is zero play. It is solid. And that's one thing I'm happy with the setup. I wanted to make sure I did something that was safe and had a good high quality to it. Now these things don't have to just look. I mean, they can't just look good. These things have to function. The heat treat, the tempering, the sharpness, the functionality of these knives, the machining, the finishing. You know, this can't just look, aesthetic. These things I'm making, they have to perform. They have to be functional. So let me know what you think. Is this kind of, you know, not full, it's just kind of a fool's errand trying to make a knife that's a push dagger? I don't know. It came out nice. It's interesting. Tell me what you think. It's a utilitarian thing or just an aesthetic thing? Let me know. I appreciate you guys watching. Leave a comment. Tell me what you think. I'll see you guys on the next one. Thank you.